Hey everybody, so evidently my section 4.7 video uh, never got uploaded. So what I'm going to try and do right now is give you a quick overview of 4.7. So a lot of it has to do with the unit circle, and I'm just going to give you some notes right now. So the unit circle basically is based off of special right triangles, 30, 60, 90 ones, so 30, 60, 90, and 45, 45, 90 triangles, and all of the exact values that go around with that. So we kind of know that on a 30, 60, 90, the hypotenuse is always twice as long as the short leg. Whatever the short leg is, the long leg is whatever that is times square root of 3. And on a 45, 45, 90, we know that this is isosceles, so this is a 1, 1, and then that's a root 2 situation. And basically a unit circle is nothing more than all of those 30, 60, 90, and 45, 45, 90 triangles going around here. So one of the things that we'd have right here is if I split this first quadrant up into this first thing being a 30-degree angle, and this next one being a 45-degree angle, and the next one being a 60-degree angle, and I was to drop this straight down, I know that this would be 1, because it's called a unit circle, so the radius is 1 unit of length, which means this would be a half, and a half times the square root of 3 over 2 goes right there. So we know that that coordinate has an x value of root 3 over 2 and a y value of 1 half. And then I think you guys know on these ones, same reasoning. This would be root 2 over 2 and root 2 over 2. Because if the hypotenuse is 1, and then I drop these legs down, and these legs are congruent for what's left there, then I get 1 over square root of 2, which becomes square root of 2 over 2. Okay, so these are the exact values as we go around, and we know that if this is square root 3 over 2 and a half, then this one is a half and square root 3 over 2. These are all exact values. You could put them into your calculator and get the decimal equivalents on those too. It's not a crazy thing. But we want to know what the angles are, the 30, 45, and the 60, but we also want to know what they are in radians. So that's a pi over 6, and this is a pi over 4, and this is a pi over 3, and we know that all the way over here on a unit circle is pi, and I know if they would have realized, maybe they wouldn't use pi as that, because pi is actually half of a circle, and most of the time when we think of pie, apple, strawberry, cherry, whatever, we think of a whole circle or a whole piece of whole pi. So do know that that's pi, which means this of course is pi over 2, and this is 3 pi's over 2, and all the way around 0 or 2 pi when we go all the way here. So when we try and break this sucker up into these other sections over here, and we're trying to do the values, all of these, square root of 3 over 2 and 1 half, square root of 2 over 2 and square root of 2 over 2 and 1 half and root 3 over 2, are the same things over here. The only difference is the x values of whatever's over here become negative, because now we're going to the left. Is that okay? And then when we flip it down into here, all of them are negative, negative. Oops, sorry. Negative, negative. And then over here, these ones are all positive, negative, in terms of the same locations as we just use symmetry and mirror them over this stuff. So how do I figure out some of these things? So what is this in terms of radians? Well, this is a, splitting it in the middle, that's a 45-degree angle right there, right? So there's a 45-degree angle there, and a 45-degree angle there, and a 45-degree angle there. So if that 45-degree angle is normally pi over 4, I have 1, 2, 3 of those 45-degree angles, or 3 pi's over 4. And that's the same thing I can do with, say like this angle. This angle we know down here is 30 degrees, right? So I ask you, how many of those 30 degrees are there in 180 degrees? Because that's the equivalency right there, right? So how many 30s are in 180? Well, there's 6 of them. So if I was to go here, I know that I've got, and this is probably hard to be able to tell, but in 90 degrees I've got 3 of those ones. And then if I come all the way from here, and this is the last time I'm going to draw something on here, all the way to here, I have all but the last one of these 30 degrees. So I have 5 of those 30 degree angles. So that's 5 pi over 6, or 5/6 of a pi. Okay? And that's how we can get all of this different stuff. So 4/7 deals with a whole lot of these things. So here we go. Here's some of the stuff that will help you with section 4/7. And again, stop the video anytime you need to be able to get into this stuff. So here's our basic triangles. So one of the things we're going to do is we're going to say, hey, if I want to know what cosine inverse is of -√2/2, and I want to put that in radians, what the heck does that mean when we have that? That basically means this, right? We want to know what cosine inverse of -√2/2 is. So if I did cosine of cosine inverse of -√2/2, it would equal cosine of x. I'm just taking the cosines of both sides, right? So you know cosine kills cosine inverse. So I want to know what angle is equal to -√2/2. Well, I can go to my unit circle if I need to. Here we go. I know that a 45 degree angle right here, right, is a √2/2. Yes, and cosine is the x value, right? I should put that in there for you. So cosine, sine, right? Cosine is the adjacent, sine is the opposite. And we can use that like this because we know on a unit circle the hypotenuse is 1, so whatever it is divided by 1 is still that answer. Okay? So I need it to be negative. So these are both positive. So where is the first time that cosine is negative? Well, it's over here. So what is that angle when I go over here? That's a 45 degree angle into this quadrant. So 1, 2, 3 45 degree angles. That's 135 degrees. Or if the question asks for it in radians, we simply switch it out to 3 pi over 4. And that would be our final answer. Is that okay? This one's saying, hey, what angle? Again, what angle again? When we do a sine of it, gives us -1. So let's go ahead and do a quick little sketch of our graph. And you can graph these on your graphing calculator too. That's what sine looks like, right? So sine starts out at 0, goes up to 1, comes back down to 0 again, hits at -1, and then comes back up here, and you know that it repeats every 2 pi. So if I wanted to know sine inverse of 1, let me just go, hey, that looks like that's 90 degrees. And sine inverse of 0, that happens 3 times between 0 and 2 pi inclusive. But -1's right here. That's that one right there. So that's 90, 180, 270 degrees. Or, if I want to convert that into radians, right, that's pi over 2, pi, 3 pi's over 2. So that would be my final answer there in terms of radians. Hoping that follows okay. So this one right here says, what's the tangent of the cosine inverse of √3/2? Well, we're going to try and figure this out. So I want to know what angle first gives me a cosine inverse of √3/2. So let's draw our little picture here. I'm just going back to the ones that give us √3/2. So that's the 2, 1, and √3. That's a 30, 60, 90 triangle, right? 30, 60, 90 triangle. And this is positive. And I know these things happen a couple different places, but we're going to use the ones that our calculator would give us too on this. So √3/2 for cosine. is adjacent over hypotenuse. So that means that that must be a 30-degree angle, right? So that is 30 degrees. So I want to know what is the tangent of 30 degrees, since that equals 30 degrees. Well, the tangent of 30 degrees, tangent's opposite over adjacent, so that's opposite right here, over adjacent right here, that's 1 over root 3, which equals root 3 over 3, and that would be my final answer there. So when we're looking at one of those, that's what we're trying to do. Okay. So this one right here, sine inverse sine of 2 pi over 3. My first initial instinct is, hey, sine inverse kills sine, yay, it's just 2 pi over 3, right? That's totally logical, totally would make sense. However, we're going to hold off on that for just a second. Because remember, there can be multiple solutions because sine's positive in a couple different places. So let's take a look at where this is on the unit circle. And 2 pi's, that's all the way around, right? Divided by 3, so if you think 360 divided by 3 is 120 degrees, so we know that we're talking about this one right here, right, that 120 degree angle. Is that okay? And then if I do this here, I know that this is 1, or let me do it the whole way, 2, 1, and root 3, and that one's negative right there. But sine is opposite over hypotenuse, so that's square root of 3 over 2. So I really want to do the sine inverse of root 3 over 2, and it turns out the sine inverse of a regular root 3 over 2, because remember, sine's positive in both of these places. So we really need to find the regular one, which is right there. So, because, you know, as we go around the circle, we are always going to use the first time that it happens to be positive. So that is a 60-degree angle right there, which is the same thing, because you know it's the same at 60 and at 120. So if it's 2 pi over 3, we actually want to use pi over 3. That's our first one, first time that happens. Okay. Down here to something like this, they're going to ask you about what graphs look like, and they're going to ask you a whole bunch of different questions. So what you need to be able to do is kind of graph this out, and you can use your calculator. Calculator would be awesome in this section. So y equals cosine x. So I'm going to start cosine right up here. And we'll come down and back up again. So cosine looks like that, right? And they'll just ask lots of different questions. So, and honestly, I don't know which one they're going to pull up, but let's say if you get cosine, then you're halfway done. So I want to ask a question about this domain of cosine. So cosine keeps on going, right? Keeps on going and going and going. The domain is the x values, so that would be all reals. Good deal. The range is the y values, the up and down, right? So the range would go from -1 to 1, inclusive, because it can go all the way down to -1 and all the way up to 1. That's how far it goes. Increasing and decreasing, well, it's increasing in a lot of different places. It's increasing from pi to 2 pi. It's going to increase again from 3 pi to 4 pi and all of those different things. So there's lots of increasing. And it's decreasing from 0 to pi and then decreasing. So it's increasing in an infinite number of different intervals and decreasing. Symmetry, does it have symmetry? Yeah, look at that. It has symmetry. It reflects over the y-axis. Does it have any extrema? Yeah, it has extrema. It has extrema at 0 and extrema at pi and extrema again at 2 pi and at 3 pi and bounded. Yeah, it's bounded. It doesn't go above this and doesn't go below this. So again, a lot of those different questions about what the graph does do that. And if it gives you a funky thing like, I don't know, cosine inverse or secant or whatever it is, I don't know, feel free to graph and just look at the graph and be able to do those ones. Okay, so wrapping up 4-7, one of the other things you can do, again, just like I said on this one, is use your calculator to analyze any of the graphs. So if they give you some graphs and ask you some questions, fire it up, throw it in there. Okay. Next, number 7, we're trying to solve this little equation. So it says 2 cosine x equals square root of 2, and we're trying to solve that one. So I don't know what angle, when I double it, equals the square root of 2. Well, I'm hoping you can just do some algebra. Divide by 2, divide by 2. That kills that. So I want to know the cosine of what equals square root of 2 over 2. Well, root 2 over 2 again is our 45, 45, 90 triangle, right? So, and this is 1, then I have to divide by the square root of 2, which becomes 1 over square root of 2, which is square root of 2 over 2, then square root of 2 over 2, and cosine, right? Cosine is adjacent over hypotenuse. Hey, look at that. So we know we're talking about a 45-degree angle. So if it asks you to solve for it in degrees, it'd be 45. If it asks you to solve for it in radians, it'd be pi over 4. And then you got to look at this. Well, what happens? All students take calculus, right? So cosine's also positive way over here in the 4th quadrant, right? So I also need a 45-degree angle down in here, and I don't know if the text, the Pearson's going to ask you to do this, but I just want to make sure that you're okay with this. So I need a 45 over here, so that means 45 and 315 work. And pi over 4 and, look at this, ready? Bunch of 45-degree angles. 1, 2, 3, 4, 5, 6, 7 pi's over 4. 7 of them. And that would be what's going on. And then the last one, these are a little tricky, but I think you can do this. So this is cosine of sine inverse of x. And we want to know what that equals. And we're like, what? So sine inverse of x means sine of what is equal to x. Well, the only way that sine can be x is if I let this angle theta, have this be x, right? Some unknown. And sine's opposite of hypotenuse. So opposite is x, hypotenuse is 1. So what's x divided by 1? X. So we know that that must be there. And then we want to know what the cosine is of that angle. Well, that's what this thing is, right? So I'm like, how do I figure that thing out? Well, do I have 2 sides of a right triangle? I do. So I just have to do the Pythagorean theorem to find out this one. So my question mark right here, I know that question mark squared plus x squared equals 1 squared. Pythagorean theorem, yeah? Still trying to solve for question mark because I don't know what it is. So I'm going to subtract x squared. So question mark squared equals 1 squared, which is 1, minus x squared, because I moved that to the other side. And then how do I get question mark if I have question mark squared? Well, of course, I square root it. So question mark equals. Now, technically, if I square root a variable, I have to do plus or minus, but because I'm dealing with a distance, I'm going to ignore that. So that's the square root of 1 minus x squared. So if I have a problem like this, and I got an x in there, something like that, instead of an actual number, then I just draw up the triangle with that in that location, and then solve for the other one, going through that stuff. So what does this equal? This equals the square root of 1 minus x squared. Hey, again, as you know, a lot of this stuff was unit circle stuff, and I'm hoping this was pretty good. Stay with me, and I will be having several of these breakout sessions coming up. I just wanted you guys to get a chance to work into some of these problems, but I'm going to be doing some Zoom meetings. If you're watching this currently during the spring of 2020, during the crazy coronavirus times, again, I'm going to be doing some Zoom meetings pretty soon with you. If this is several years in the future and you're going through some stuff, then hey, fire up. We made it through. Here we go. You guys take care, and we'll talk again soon.